Hello everyone, myself Girish with ANSYS Structural Tutorials. In this session, we'll go ahead with the basics of ANSYS and the user interface. Agenda of this particular session is to deal with the static structural analysis, the basic analysis, and the engineering data, how we can access the material database and how to cross-check the material properties. Next thing is to deal with the geometry, how to import the geometries. If you want to create the geometries, what exactly you can do. Then the model setup, meshing, and dealing with the boundary conditions in the setup, and solution stage, how exactly you need to define the post-processings and what and all the results you want to extract in the solution phase. We'll just see that one. And the result preview window, the post-processing, how to get the results which we are looking for, how to set up our post-processing stages by using the different outputs like deformation, stress, and factor of safeties and all. Okay, let's start with the session. So here, if you are new to the ANSYS, if you have installed the software, how to access it now. So you can directly go to the search and you simply type for ANSYS. Okay, you can directly access to this open file locations. From here you need to use this Workbench 18.1. So you can right click on it and you can pick to the taskbar. As I already pinned it, you can simply unpin this, and now if you want to pin it, right click and select pin to taskbar. So next time you can double click on this icon, or else you can directly go to this taskbar and access the Workbench. Okay, so this is how you can browse the software for the first time if you're using it. Just remember how to just customize your interface. Okay, so depending upon the system configuration, it's gonna take some time to load your software. Okay, I recommend you to utilize the 32 GB or 64 GB RAM with better graphics card to work on the software. Okay, so this is the project tab. These are the toolboxes, the analysis systems. You will have the all the types of analysis tabs. Let's say if you want to deal with the static structural, you can simply select that one and drag and drop it. We have the different systems here. So right now just showcase all the types. So this is the component system, and then we have the custom systems. You can use these all the pre-stressed models and different steps, and these are the design explorations. You don't need to remember these all the steps for now. Okay, we'll see the few steps with respect to menu bar. We have the file, there you can save and open the files. View settings, okay, you can set your particular user interface here, and these are the tools and the unit systems. Let's say if you want to customize your unit system here, you can come to this units tab and you can just customize according to your requirement. Okay, let me just deal with the analysis systems for now. I'll just expand it from here. For the basics, I'll just deal with the static structural. So if you drag and drop it here, you'll have the initial stage to define your name of this study. Okay, after that you can use the drop down. Instead of double clicking on it, you have the drop down, and from there you can select the rename study. Okay, here I'll just define the name as Introduction to ANSYS. So this is a basic analysis which we are just dealing with. Okay, fine. So the first thing is to deal with the engineering data. So you can simply right click on it, or you can simply double click on it to just access it. Okay, so in this engineering data you'll have all the kinds of material data be stored. Okay, so this is the default structural steel will be there. So with that you'll be having the properties, the density, mechanical properties. Okay, and then if I search for the isotropic elasticity properties like Young's modulus, Poisson's ratios and all, so you will have the all the kinds of properties which are required for the analysis. Okay, so this is the engineering data source. From here you can access all the kinds of materials. Like in the general materials, you could see we have the different materials like structural steel and others. So in the non-linear materials, we'll having the nonlinear analysis materials. Okay, and this explicit materials will have the materials with related to the explicit dynamic analysis, and same thing for elastic and hyperelastic materials and the magnetic materials as well. Okay, so if you want to customize these materials, you can simply create a new tab, and you can simply change the material database. That I'll explain in later sessions. Okay, so right now let's say I want one more material to be added into my account. I'll just select this aluminum alloy, and I'll simply click on this plus icon to add into the project which I'm working on right now. So you can simply click on the project tab to switch here. So once you customize your engineering database, you can simply utilize this geometry. Here you can use the workbench to create the material, or else you can just import it. So we have the space claim geometry to create a material, and we have the new design model geometry. These are the ANSYS Workbench models. They're quite easy, but right now I'll try to create a model by using the best design software, that is SolidWorks. I don't want to waste much time to create the model, so I'm familiar with this software, so I'll use the workbench. The front plane, I'll simply draw a simple rectangular block with a hole. Okay, you can define the dimensions. Let's say this should be of 250 and 100. Okay, and the center circle of a radius 26, I'll assign it. And these are the random values. I'm not copying any of the components or any of the models from other softwares. They will have some privacy or some restrictions to access the materials, right? So let's say I'll define the thickness here, 25. Okay, this is the on material model. I'll save this one. You can save this as a universal step formats. Okay, Parasolid or whatever. So I'll just select this step 2014. I'll save it on the desktop. Name it whatever you want. Introduction to ANSYS. As we are dealing with just basics, so I'll simply select this name. Okay. You can even use the ANSYS Workbench to create the model, but for me it will take more time because I feel that is somewhat lengthy process. So I'll quickly import this model now. So we have the import geometry. You can browse the file locations. So directly I'll select the step file. Even you can import SolidWorks files and CATIA files and other formats if you install it in the prerequisites. Now I'll go ahead with the model tab. You could see the engineering data and the geometry tabs are green checked, in the sense the material and the geometry has been imported. Now the model stage, what it does is you can able to assign the material and you can mesh it. It will automatically switch to the setup tab and the solution tab to just apply the pre-processing stages and the post-processing as well. Okay, I'll showcase how it does here. So this is the user interface, how it gonna look like for the first time. So you can switch to the graphics here. The geometry will be available, so it will be shown here like this. So ANSYS 18.1 I'm using. The geometry is ready, and the project tab is also here at your left side. Okay, I'll close the software SolidWorks to just avoid the RAM usage. Okay, so this is a project tab. In the model we have the geometry, and this is the solid model. So here you could see the material assigned. So as I said, I had imported even aluminum alloy as well. So if you want to assign it, you can assign it. If you want to change it, you can directly change it from here. So you can even add the multiple material into your project to cross check the same. Okay, the material assignment is done. The meshing, there are different types of meshing available. So the direct method is to just simply assign the sizings. You can use the different types here: program, control, and linear, quadratic. Let me just showcase. If I use the linear, what happens here. So I'll use the automatic method here. I'm not gonna change anything. By default, software gonna assign the mesh. So this is the linear. As you could see, the mesh sizes, and you can even change it to quadratic. Let's see how it's gonna look. So you can see the shape there. The quadratic will arrange according to the requirement. The linear will give you the first order elements. Remember that. Okay. So this is the program control. So it will try to refine the mesh according to the model. So these are the different sizing methods. Okay. Let me just showcase one more thing. Or if you want to manually just edit entire meshing techniques, so we have that options as well. I'll cover that one now. Here we have the sizing, element size. By default it is here. We can just change it. Let's say 5. Okay, unit system, it's in metrics, so I'll change it to a millimeter. Okay, the first step we need to remember, or else the units will be in meters. So fine. Here the element size should be let's say it's 5. Okay, the adaptive method, you can choose the curvature based or proximity or uniform. So I prefer the curvature based one. You can even choose any other methods to cross check the same. Okay, so here you can define the maximum size and the growth ratio. So the growth rate should be approximately 1.2. remember that by default. So with respect to 5 mm thickness, you could say this is how the mesh will be generated. Okay, this is one method. Depending on the curvature based and the size, we have assigned it as 5 mm there. So these are the different options to just again refine it by using the fine for the relevant center and the span. So here we have the different options for the mesh editing and the mesh controlling. Okay, let's say the mesh method. The sizing and the refinement is very important here. So later parts I'll cover later. So I'll just select the method. Here I'll just choose the entire model. The body has been selected. Here the method, you can choose which type you're looking for. These are the advanced meshing techniques. So right now you just remember these things. Later on we will implement these things. Okay, so the element order, quadratic or linear, here you can define it. So this is the manual method. Okay, once you assign it, you can directly mesh it accordingly, just to cross check how it is. Okay, so even we have the sizing option. So by just selecting the geometry and defining the element size as per the requirement. Okay, so I'll add it again. The element size you can define, and the size function, the curvature based, the growth rate and all. Okay, I'll define it as 1.2. we'll see what happens now. This is with the body sizing. Okay, to just preview the mesh, you just need to click on the mesh tab, and this is how it gonna looks like. Okay, you can even delete one of these. So let's say I'm just dealing with the manual method. You can define delete the automatic method. You just need to update it again. Okay, once you release something, it will ask you for the updation. Remember that. Okay, so this is done. Let's say I want to define the multiple layers here at the circled regions. So while dealing with the CFD and all, you need to do that. To do that one, you can directly go ahead with the mesh controls, and we have the different options. From here I'll choose the refinement. Okay, even you can choose the inflation as well to define the multiple layers. So in this, let's say the boundary it will ask you for. So I can use the different selection methods like the surface and the edges. So I'll define the body here, and the boundary I need to select the face. So by default it will select the face selection only. By holding the control, you can able to define the multiple faces. The number of layers, you can increase it to maximum the values up to 10, 12, whatever it is. Here I'll select only 3. The growth rate is already defined. I'll update it. Now we'll see how it gonna looks like. Okay, so you can see this is how the mesh is generated with respect to the inflation layers. Okay, the ANSYS software is intelligent enough to just select which kind of mesh is fine for the required models. Okay, so for now I'll just choose the simple method, that is boundary sizing. Okay, once you are done with that, we have the static structural. So here you can define the boundary conditions. I'm gonna define the fixed effort. There are 2 ways. One, you can simply fix the edges by just filtering to the edge selection, or else you can fix the face. But the fixtures is all about the practical conditions. Let's say you are gonna weld this one, so we are going to just fix the edges, right? Yeah, so same thing assigned here. The face I'll select. I'm gonna apply the force. The force values here you can define it on the face, and the magnitude, let's say 10,000 Newton. Okay, yeah. So the direction, you can change it by using the direction arrow marks. Well, so I'm done with the fixtures, and here I'll assign the solutions, what exactly I'm looking for, the total deformation, and even the stress values, maximum, equivalent 1 minus stress, and the stress tools we are having. We do have the fatigue tools and the contact tools. For now, I'm not going to explain these all the steps. So what exactly I'm looking for here is the stress tool, and I'll simply choose the equivalent stress. So from here we can able to extract the factor of safety values. Okay, so how to define the solutions, what I'm looking for, and the boundary conditions as well. I'll simply solve it by using this icon, or else you can use this one, solve. So it will take some time according to the system configurations which you are using. Okay, if the model is complex, it's gonna take more time. Yep, it's done. So here you could see everything is grain checked. The results are ready to preview. The total deformation you could see it is 0.005, and the stress 39 somewhat. Okay, and you could see only the edges as the stress regions because I have selected edges in the fixtures. The deformation is scaled up, so you can even choose this true scale from this option to just define the scale options. Okay, so here the displacement is negligible, so 0.005 is the factor of safety is normally 15 everywhere. At the fixtures it is 6. For the metals it should be 2 to 6. The factor of safety should be, remember that. Okay, now I'll try to change the fixtures. We'll see, instead of the edges I'll just select the face, so you can simply filter it and apply, or just rerun the study, that's all. Okay, now we'll see the results, how exactly gonna vary the displacement. Okay, there might be a slight difference, not more. Total deformation is same, 0.005, no changes. You can even change the results preview, and here you could see the stress. It was 39 before, it is 13. Okay, depending upon the fixtures or the stress values will also change. Okay, before it was at the edges, but here it is at the location of the circle. Okay, the force per unit area. So you can use the probes to select the maximum and minimum stress values, and even you can use the manual probing options. Okay, you can even use this options to just define the meshes as well. The smooth contours and all, you can define these all the post-processing tools here. Okay, we do have the manual probing, you can select this option to just define the locations where you want to see the results. Okay, yep. After this, if you want to section this to just see how exactly the section view gonna work, we do have that option to section it. So I'll just remove these probes. I'll simply use the normal preview. Okay, yeah, so this is the new plane section view. So from here you can simply drag a line to just cut it. We could see the preview. Okay, you can uncheck this, or if you want to delete that, you can even delete it. So I want to create a new plane. I'll simply cut this one like this. Could see the preview now, right? So this is how you can use the section planes. We have the elemental preview as well. So let's say I'll showcase that as well. I'll cut it like this, and now you can activate this elemental preview. Now if you want to just have a more clarification according to the meshes, you could see the mesh elements, right? Okay, this is how you can utilize the section planes. So these are the few techniques to deal with these. Now let's deal with the report generation. We have the preview pane. So from here we can just preview the results. So this is equivalent stress with respect to the section planes which we have chosen. So this is the report generation tab, so where the report will be generated, okay, according to the section planes. So whatever the workbench is active, according to that it will generate the results into report previews. Okay, it has all the results. You can able to access, okay, the total deformation and everything. This is the geometry. So I'll capture the images to include into the report. So you can use the this option to just include the images there. For this I'm just gonna include these figures to the report. So once you are done with that, the report will be again generated according to the modifications which we have done. Okay, yeah, so now you can access the report. Now you could see the results, the total deformation, and the image which we have included, the result summary as well. So if you want to print out this one, you can even print it up. Okay, that's all about this. To summarize what and all we have covered, I'll just go to the summary page. So here you could see we have gone through the static structural analysis, the basic one, and we have gone through the engineering database. So how to just deal with the material database and where are the materials located, which type of materials are located. Okay, and then the geometry, creating geometry as well as the importing geometry. If you are using the different software, or if you want to use the own user interface of ANSYS, you can even do that one. Okay, then we have the model processing. There we have just imported the model there, and we have defined the material which we are looking for, and we have meshed it with respect to different meshing types. And then setup, in this setup we have just defined the boundary conditions like fixtures and the loading conditions, and then we have even defined the solutions which we are looking for, and then we have just gone through the results, the post-processing stage, different results like stress, the total deformation, and the factor of safety. Okay, what exactly the factor of safety is, the whether the component gonna withstand that much load or not. We can just cross check that one. Okay, with respect to the yield strength, what exactly the component has, with that the maximum stress value to the material, whatever the material the ultimate stress is there, from that you're gonna get the factor of safety. Okay, for this structural steel will be having the 250 megapascal as a yield strength. So whatever we got, it is 39 and 13 megapascals are less than that, so factor of safety is more than 2, so the components are safe. So whatever the regions you are seeing in the red, so it shows that there the maximum one mesh stress is located, not the failure, remember that. Okay, And then we have gone through the sectioning, probings, and the report generation as well. So that's all about the basics of ANSYS user interface and the basic simulation how we can conduct on the ANSYS user interface. Okay, well, thank you all. Please do support us and do subscribe us. Thank you. Stay tuned.